Yes, welcome back to my channel. Students, today we are going to learn Chapter 1 Matter in Our Surroundings of Class 9. A small request from my side is that this is my first video in my YouTube channel. So I need your support. Share this video to your friends. From now onwards, we'll study matter in our surroundings. So students, as we look at our surroundings, we see a large variety of things with different shapes, sizes and textures. Everything in this universe is made up of material which scientists have named matter. The air we breathe, the food we eat, stones, clouds, stars, plants and animals, even a small drop of water or a particle of sand. Everything is matter. Next. Early Indian philosophers has classified the matter in the form of five basic elements, which is called as Panchatattva, which are air, earth, fire, sky, and water. According to them, everything living or non-living was made up of these five basic elements. Okay. Next, physical nature of matter. Matter is made up of particles. Since for a long time, two schools of thoughts were there. One school has supported the matter to be continuous like a block of wood, and whereas other school has told that the matter was made up of particles like sand. This activity was not important, so we'll go into another portion, which was characteristics of particles of matter. Particles of matter have space between them. Particles of matter are continuously moving, that is, they possess what we call the kinetic energy. The kinetic energy means as the temperature rises, particles move faster. So we can say that with increase in temperature, the kinetic energy of particle also increases. This is the definition of kinetic energy. Next, states of matter. Since students, as we have already studied that there are three states of matter, which were solid state, liquid state and gaseous state. First, solid state. There are so many solids like a pen, a book, a needle and a piece of wooden stick. All of the above were the examples of solids. We can we can observe that all these have a definite shape, like definite shape, distinct boundary, fixed volume, which have negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force, as if we given as if we give any force to the objects, they don't change, the shape remains same. Okay, so these were the examples of solid state. Liquid state like water and other liquids were called liquid state, as the liquids have no fixed shape but have a fixed volume. The second state was liquid state. As we observed that liquids have no fixed shape but have a fixed volume, they take up the shape of the container in which they are kept. As we fill our bottle, as our, as we fill the bottle with water, the water takes the bottle shape. If we fill the water in a container, the water takes the container shape. The liquid state takes the object takes the shape of the object in which it was kept. Okay, all living creatures need to breathe for survival. The aquatic animals can breathe underwater due to presence of dissolved oxygen in water. And this is the important bit here, the rate of diffusion of liquids is higher than that of solids. Okay, next, another state called gaseous state. Students, I'll upload these activities in the form of YouTube shorts. For those activities, you can refer my YouTube short videos. Okay? Here, can matter change its state? We all know from our observation that water can exist in three states, which are solid as ice, liquid as the familiar water, and gas as water vapor. Okay? Next, on increasing the temperature of solids, the kinetic energy of the particles increases. Due to increase in kinetic energy, the particles start vibrating with great speed. This is the important bit. The melting point of a solid is an indication of the strength of the force of attraction between its particles, and the melting point of ice was 273.15 Kelvin. The process of melting, that is change of solid state into liquid state, is also known as fusion. When a solid melts, its temperature remains the same. So where does the heat energy go? The temperature of the system does not change while we are melting. After the melting point is reached, till all the ice melts, this heat gets used up in changing the state by overcoming the force of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the breaker and is known as the latent heat. The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure is known as melting point. Students, this is the important bit. Okay, I'll repeat once again for you. The amount of heat energy that is required to change 1 kg of solid into a liquid at atmospheric pressure at its melting point is known as latent heat of fusion. So particles in water at 0 degrees Celsius, that is 273 Kelvin, have more energy as compared to particles in ice at the same temperature. When we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the force of attraction of each other. Particles in steam, that is water vapor at 373 Kelvin, have more energy than water at the same temperature. This is because particles in steam have absorbed extra energy in the form of latent heat of vaporization. Next, effect of change of pressure. We have already learned that the difference in various states of matter was due to the difference in the distance between constituent particles. Okay, applying pressure and reducing the temperature can liquefy gases. As you can, as have you have heard of solid carbon dioxide, which was solid CO2? It is stored under high pressure. Solid CO2 converted into gaseous state directly on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is known as dry ice. Students, what is called dry ice and what is the use of it? As you can know that dry ice was used in melting of clouds, which will causes the cloud burst. Many states and countries have utilized this technology to get artificial rains whenever there is a scarcity of water. Okay, another important part was evaporation. What is called evaporation? Do you know some examples from everyday life where change of state from liquid to vapor takes place without liquid reaching the boiling point? Okay, evaporation. At a given temperature, in any gas, liquid, or solid, there are particles with different amounts of kinetic energy. In the case of liquids like water and another liquids having higher kinetic energy, it is able to break away from the force of attraction of other particles and gets converted into vapor. Okay, if we pour some water on the surface of any floor, and after some time the liquid melts away and the liquid disappeared. This is due to the evaporation, and the liquid turns into vapor form and it moves into the atmosphere. Exactly, this phenomenon was called as evaporation. You have studied the evaporation in your previous classes. Okay, next another activity is here. I'll upload these activities in my YouTube shorts. Okay, no need to worry. What you have learned, students, these points are very important. These are like a summary to your chapter, so please pay your attention here. Okay, matter is made up of small particles. There are three states, as you have already studied, that solid state, liquid state and gaseous state. The force of attraction between the particles are maximum in solids, intermediate in liquids and minimum in gases. Okay, maximum in solids, intermediate state in liquids and minimum in gases. The space in between the constant particles and kinetic energy of the particles are minimum in case of solids, intermediate in case of liquids and maximum in case of gases. Okay, these two study properly. The arrangement of particles is most ordered in the case of solids. In the case of liquids, layers of particles can slip and slide over each other, while for gases there is no order. Particles just move about randomly. The state of matter are interconvertible. The state of matter can be changed by changing temperature or pressure. Sublimation is the change of solid state directly to gaseous state without going through liquid state. Okay. Deposition is the change of gaseous state directly to solid state without going to liquid state. Boiling is a bulk phenomena. Particles from the bulk of the liquid change into vapor state. Evaporation is a surface phenomena. Particles from the surface gain enough energy to overcome the force of attraction present in the liquid and change into the vapor state. The rate of evaporation depends upon the surface area exposed to the atmosphere. There are two latent heats are there, which were latent heat of vaporization and latent heat of fusion. Okay, we will understand the definitions of two latent heats. First one is latent heat of vaporization. Latent heat of vaporization means the heat energy required to change 1 kg of liquid to gas at atmospheric pressure at its boiling point. Okay, next another one is latent heat of fusion. The latent heat of fusion means the amount of heat energy required to change 1 kg of solid into a liquid at its melting point. Okay, don't get confused here. The change of 1 kg of liquid to gas at atmospheric pressure is called latent heat of vaporization, changing from liquid to gas. Next, change of 1 kg of solid into liquid from solid to liquid at its melting point is called latent heat of fusion. Okay, students, I'll give a task to you. Answer all these questions in my comment section. Okay, I'll give quick replies to your queries. I need answers from all of you. There are 9 questions are there. Please try to solve these questions. I'll upload the videos daily of class 9th 10th. If you need any guidance and any support, feel free to contact me and put all your queries in the comment section. I'll upload all the chapters of all subjects. Okay, first one is science, next I'll upload bio, social, English, and other subjects. Okay, thank you all of you. Bye bye.